Did you roll your eyes, Mary?
All right. Well, I'll say good afternoon, everyone. Thanks for joining the Thursday, April 9th edition of the Ham Science Zoom call. Today, we've got a nice group here. I'm sure we'll have time for some open discussion afterwards, but we'd definitely like to start the meeting with Tom Crowley, KT4XN. And before I forget, I want to thank Bob Gerzoff, WK2Y. Bob's been a member of HamSCI, the community, for quite a long time, presented at many workshops, but he put me in touch with Tom, and hence deserves all the credit for today's presentation and for bringing up the subject. So Tom, it looks like Zoom is working well for you. Do you want to get started?
Okay, thank you. Good afternoon, everyone. Now I have to go back and remember how to put the presentation on here. It's been a while since I've done one on Zoom.
That's fine. I'll just remind everyone to mute their computers. Tom, do you want us to ask questions during your presentation? Would you prefer that we hold them until the end?
Ask questions, and if it's going to take too long to answer, or it's way ahead of where I am, then what we'll do is we'll just move it to the end and move it later.
Great.
Okay, could someone remind me on how to?
There should be at the very bottom of the screen a share icon. It's kind of a box with an up arrow, but I see it on the bottom of my screen on my Mac.
Yeah. I got a whole bunch of crap down there that doesn't belong. Hang on, let me move it out of the way. It's not moving. Okay. How are we going to do this?
Sometimes, Tom, when you move your mouse around, it'll suddenly appear at the bottom.
Yeah, I've got the on the bottom is all the Microsoft crap.
Move your mouse around and you should see
And I'm trying
audio, video, and then eventually share.
Yuck.
You could also try Control Shift S.
Say that again.
You could also try hold down the Control and the Shift key and tap S.
Oh, S for share. Okay, that makes sense.
Control Shift in.
S is in Sam.
Well, that was the wrong thing.
On mine, it shows Alt S.
Yeah, I'm doing that. It's not working quite the way I'd like it.
Would it be Alt S? Alt as in Sam?
It's
No.
Control Shift S as in Sierra.
Yeah, that's what I'm trying.
On the bottom, do you see a round circle that says more?
Yeah, I can't get rid of the Microsoft crap across the bottom.
You don't need to get rid of it. It's above that when you move your mouse. It's above.
Yeah, I've tried that too.
Wonder if his window's too large and it's overlapping.
Let me try one thing. I've got copy saved, markup, visual search, nothing of what I want. Why is that? What is going on? Okay. Do you have that? Do you have anything?
No, we're not seeing anything that's talking about sharing yet. For the heck of it, I could try and make you co-host. That might change your menus a little bit and cause the share button to appear.
Okay.
Let me try that. Yep. So you're a co-host for what it's worth.
He has to serve us cookies.
Now I've lost my Zoom image. Wait a second, I'm on.
Well, the good thing, we're mostly all volunteers, so time is not money for us, so we're fine.
Let me try screenshots, see what happens. Anything?
Not yet.
Tom, do you know how to mute yourself to make the little microphone appear in the lower left that you could put a red line through? Do you know how to do that?
Like he just turned his video off.
Well, it's a day for technical difficulties because I'm not sure if anybody's tried to reach the hamsci.org website today, but there's a DNS failure and you can't get there from here.
Let me try it on a different PC.
Sure. The HamSCI website is definitely up and active if you use the IP address, which of course nobody knows, but probably Nathaniel. But so he was in class when I asked him about it earlier. So hopefully he'll be working on that later today. And it's not April 1st, so we can't blame that.
Hey, Gary, could Tom send you the slide presentation?
That's one option. We've done that in the past and it's worked okay. I know Tom was also going to show us some other things, but that much we could do if we had to.
I've got the muon detector up and running, so my plan is to show you that after the presentation.
Yeah, live demo is always appreciated.
Maybe he could log off and relog again on the conference.
Hey, Gary, can somebody remote in and take a look at the screen for him?
Yeah, that's a good question, Ron. I don't know.
I've done that before when somebody's had a problem like with some of the clubs that I'm an officer in, and we run into something like this. One of us will remote in really quick, take a quick look.
Okay.
Anyway, it's just an idea.
I'm getting 3 Toms now.
The more the better. I don't want to fiddle with screen sharing while Tom's working on it, but a brief announcement. I was just on the hamvention.org site. If anybody's going to the Dayton Xenia Hamvention this year, and if you go to the attendees menu.
Okay, do you have it up?
We're not seeing it yet, Tom. On hamvention.org, under the attendees menu, if you go to forums, you'll see HamSCI as in forum room 1 on the very first day, 9:15 in the morning. So we've got a slate of speakers lined up. We're always looking for folks who would like to talk during the booth talks too. The booth talks we share with ARISS, the satellite folks, and also Youth on the Air on and off during the day on Saturday. So a much smaller audience, usually maybe 6 people or so, but a good chance to get someone's feet wet doing a presentation if they would like.
Usually we're at the end of the day, so this is a good prime time spot. So
Ed's going to try and sell advertising, I think, because we got such a good
I will.
time.
Okay, can you hear me?
We've got audio.
Oh, God. Okay. Can you see me here?
We've got your video. We see you, but we don't see
I
the.
can't hear you. Let me. Gary, can you hear me?
Yes, I can hear you. Yes.
Okay, I can't hear you for some reason. Not sure why. Oh. Yeah. Okay. I don't know why. Gary, say
Yeah.
something.
Yes, sir. I hear you.
This way.
How's the audio on your end?
Okay. I've never had this much trouble with Zoom. All right, instead of doing the presentation, I'm just going to go ahead and talk my way through it. I apologize for that.
That's fine.
Okay, what we're going to do is we're going to talk about cosmic rays and especially muons, and we'll get an understanding of the cosmic particles and how to detect them. Cosmic rays are in showers. Primary cosmic rays collide with the atmospheric nuclei, that being molecules in our upper atmosphere, and they produce pions, electrons, and photons. Muons are created from the pion decay, and the muons are able to travel straight to the ground. So when that cosmic ray hits the upper atmosphere at almost the speed of light, it basically disintegrates into subatomic particles. The muons themselves are leptons, similar to electrons, but about 200 times heavier and with a negative charge. And of course, they're produced when a cosmic ray strikes the upper atmosphere. They're traveling at near light speed, and they're able to reach the Earth due to Einstein's time dilation. Why do we want to detect muons? We get a chance to study the cosmic radiation in the atmospheric processes, test special relativity. One of the interesting things is Einstein in 1905 and 1915 came out with his special theory of relativity and theory of relativity. And the amazing thing is that it holds true today. So we're able to do a test of special relativity with muons with a lifetime experiments. Muons are also used to penetrate into volcanoes, pyramids, reactors to see what's going on under the covers. The muons interact with matter, and as they're coming through the atmosphere, they're ionizing the atoms along that path. They produce light in scintillators. They can be visibly tracked in cloud chambers, and they emit Cherenkov radiation in transparent media. Now, Cherenkov radiation, also, if you've ever been to a site where they've got a radioactive source, typically cobalt, and it's sitting in a pond of water, you'll get this beautiful blue glow from it, and that's the Cherenkov radiation. So how do we detect muons? Scintillation detectors. When my student came to me and asked me, he said he wanted to detect cosmic rays. So I'm the chairman of the Society of Amateur Radio Astronomers grant program. So I took a look to see what I could find. The cheapest one I could find was $5,000. And I certainly wasn't going to approve that spend. So I started looking around and came up with another solution. So we can detect muons with scintillation detectors. Again, the cheapest one I found was about 5,000. Cloud chambers, which are a lot cheaper, but it's not easy to record off a cloud chamber. And Cherenkov detectors, again, produces blue cone of radiation. So what we came up with was a using two Geiger counters. The muons ionize the gas inside the Geiger tube, and this is the particular Geiger counter that we used. I'll go through pricing in a bit, and pretty much everything came off Amazon. The ionization triggers a discharge pulse, and we can see that that going. It's called a coincidence detector. It's very simple but limited. You can't get direction or the energy information off it. But for the student, he came in third place in the county with hundreds of other students competing. So I was quite proud. The problem we have with the muon is that a muon can travel 660 meters and no farther. So there's no way with a primary cosmic ray coming apart at 30,000 feet that a muon can strike the Earth. It's absolutely impossible. However, Einstein comes in with his theory of relativity, because the muon must travel 9,000 meters to hit the Earth. So how does that happen? We use a special theory of relativity, time dilation, and there's a formula for that. And if we look at it very simply, we look at the speed of light at 2.99 times 10 to the 8th meters per second. And the distance it's able to travel is 10,500 meters. So the muon can travel well into the Earth before it decays. So thanks to Einstein, we can detect the muons. And again, with the Geiger counter detectors, it's quite easy to do. So what we do is we use two low-cost Geiger counters stacked on top of each other, separate them by a lead sheet, and send the output from the two Geiger counters to an AND circuit. Both outputs must be true for us to detect a muon. So again, the muon coincidence detector utilizes two Geiger counters stacked on top of each other and a sheet of lead in between. And this will reduce false muon detection from cosmic rays. And it kind of reduces the background radiation. So I've got a circuit here, and it's very simple. The output of the two Geiger counters go into an AND circuit. Both must be true, and when they're true, we get an output out. That output goes to a program called Radio Sky Pipe, developed by Jim Sky. And I've got pictures here of how the whole thing goes together. Radio Sky Pipe will graph the results of the muons. And very simply, we kind of look at one muon on average per minute. It's interesting because you'll see large gaps and then you'll see several come together. The URL for Radio Sky Pipe, which is the strip chart program we're using, it's free of cost. You can get some added function at a cost of about $49. And it's https radiosky.com. And he's got a list of programs out there. And Radio Sky Pipe is one of them. Total cost is $223. Now, when I looked at the Geiger counters today, they're $42 each. And again, this is off Amazon. And it appears as though they may be now including the Geiger tube. If not, the Geiger tubes come out of Russia, and they're $50 each. So total price $223, which was an easy solution for the student. Again, he came in third place in the county. The student project was looking for how CMEs affect our the cosmic rays. So there's something called the Four-bit decrease, and what happens is that when we have a CME, the effects of the CME are greatly reduced by the cosmic rays, and the CMEs tend to push the cosmic rays away from the Earth, so they prevent them from hitting. So as we're looking, we see the count of cosmic rays go down dramatically for the time period of the CME. What are the applications of the muon detector? Education, outreach, atmospheric monitoring. Again, the effects of muons on CME detection, and muon tomography, looking into the Earth and into structures on the Earth, volcanoes, pyramids, and such. So in summary, the muons are abundant cosmic particles. We have several detection methods. The scintillation detectors are the most practical, although they're not the least expensive for the amateur. And muon detection supports physics research and, of course, education. And then I have a list of references in here. We'll open it up for questions, but before we do, let me just give you a quote. Science, my lad, is made up of a series of mistakes, but they are mistakes at which it is very useful to make because they lead us to the truth little by little. It was done in Jules Verne, 1896 or so. Questions?
I did take a brief second to flip over to Amazon. You can actually go to Amazon and type in Geiger counter in the search box, and sure enough, there are a whole lot of them come up. I never expected to see that.
Yeah, it's interesting when you look at it. And, the method was fairly simple, and then a little bit of work, we were able to get the whole thing going.
Now I'm sorry, go ahead, Mary Lou.
I'm sorry. How thick was the lead sheet?
I'm sorry, could you repeat that?
How thick was the lead sheet? You said there was a lead sheet between each of the Geiger counters? Maybe I misunderstood.
I'm sorry, I'm having trouble hearing.
My voice is bad as well.
I'll cover for you, Dennis. Tom, the lead sheet that's between the Geiger counters.
Yeah.
Approximately, what was the thickness of that lead sheet?
Oh gosh, less than a 1/16 of an inch. I believe I also got that off Amazon. I'm not sure. I didn't list it though. It's very, very thin.
So Tom, I have a question.
Sure.
How long did the student observe with this apparatus? And his output was then two graphs, one of CMEs and one of cosmic rays, or did he do a real correlation coefficient? What did he do at the end?
You can use a few methods to do that. There's a project called Radio Jove. I don't know if you've heard of that.
Yeah, I had a setup of Radio Joe for some years.
Okay. With Radio Jove, it also looks at CMEs from the sun. So you can track that. And that was one of the tools that I had the student use. I would send him the CMEs and the time, and then he would see if that correlated. Unfortunately, he only ran the project for 50 hours, and that's a short period of time to really detect CMEs. So unfortunately, we didn't get what we wanted out of that. The output on SkyPipe is simply when both Geiger counters trigger together, go through the AND circuit, you get a spike. And again, on average, maybe one a minute.
Now, if there were only one Geiger counter, you said you may have more noise in the system. Would that lead to more false detections, or is
well, there's no way to tell the difference with a single Geiger counter between the background and a cosmic ray, a muon. So you need both stacked on top of each other, some level of protection, and the muon will trigger both simultaneously. And that's what we're looking for. A single Geiger counter, you're going to get the background radiation. Yeah, you'll get the muons, but you can't tell the difference.
very clever?
Yeah, actually, it is. And it's, a reasonably inexpensive solution. And all the parts come from Amazon, which apparently now is our Radio Shack.
I appreciate the reference to Radio Shack because as a kid, I used to cut grass, mow lawns in the neighborhood, and my lawn cutting money would follow me right to Radio Shack within usually about an hour when I finished the lawn work. So
it was funny. I had a winter home in Northwest Florida. My other hobby is astronomy, and I'd go into the Radio Shack, go into the box, get what I needed. But I pretty much knew more about what was in that Radio Shack than the sales folks did.
yeah, their job was to sell stereos and speakers and car radios, I think.
Yeah.
But Tom, do you have a telescope?
I had a 24-inch. I had a 18-inch. When we moved into a retirement community, I got rid of those. They're both here along with the Atlanta Astronomy Club. Had a 10-inch that I imaged with, and I'm a research associate at Georgia Tech, have been for over 15 years, and I manage Georgia Tech and the Space Force Telescope out on Maui. And that's used for the tech students. I've put together some projects for them. And I've also we've used it for outreach. Our best year was 44,300 students. And using Zoom, I'd have the students operate the telescope, which was a nerve-biting affair, as you can imagine. But they did well. They were well behaved and no problems. So I was delighted.
What were the students controlling? Azimuth and elevation, or other parameters?
Basically, I would have them type in an object, and then the system would automatically take it to that object.
Find it.
and then would take a picture of it, take an image of it. At the moment, we have a problem out there. We share assets with the Space Force, and the dome is their asset. And at the moment, it's not opening the way it should. And we're waiting for them to resolve the issue. However, with their limited resources, it's they work on it when they have time, which is at the moment not very often. Now, before it was the Space Force, it was the Air Force out there, and what they do is they have telescopes up on top of the volcano on Maui, and those telescopes look at everything that flies over in space, including specks of paint and such. So they know when something is going to hit the ISS. They also look at all of the spacecraft, and it's interesting that they can see the rivets on the spacecraft. So if you put something up there, and if you want to be serendipitous and hide it, put somebody else's name on it, put another country's name on it. But it's kind of amazing. For the most part, everybody I've worked with has been a lieutenant, a captain. The airmen or security forces, and it was interesting. They went through a period about 6 years ago where they didn't wear uniforms at all. They just came in casual dress, and a new lieutenant colonel came in to run it. So now they're back into fatigues, what I call fatigues, and combat boots, sitting at a desk. So that's it. One of the things I found in retirement is you have to stay busy. We need to keep learning. We need to keep doing things and challenging ourselves. Otherwise, time will slip away on us in an unpleasant way. So I'll be 84 in 3 weeks, and this is my 4th year of working with students on projects. And it's interesting that the students pass me from one to another. So I find that enjoyable. And my student from 2 years ago was accepted at Georgia Tech. In 25, over 70,000 kids applied to Georgia Tech. 4,700 were accepted. So I was delighted that she was one that got accepted. But the STEM school is amazing. I judged the science fair in the STEM school, and to see the work, and these kids are juniors, to see the work that they do. And some of my neighbors are college professors or were college professors. I've showed their work to them, and the first question out of the mouth is, grad students? No. Oh, undergrads? That's really good for undergrads. No, juniors in high school. So they're kind of amazed at the work that these kids can produce.
That's wonderful to hear. That's good news.
Well, what I see, the folks our age, the kids aren't learning the things that they should be learning. Like in science, they didn't learn the difference between anthracite and bituminous coal the way we did. And they're getting back to cursive writing.
Yes.
In they learn cursive in 3rd grade. But, in 1st grade, they're using computers. So times have changed for us completely. And it's interesting when I look back into the 1800s before typewriters that everything was written out in cursive. So I've got my, from the Revolutionary War, my ancestor, I've got his retirement papers and his pension all written out in beautiful cursive. Well, I don't know what happened here. I'll play with Skype and try to sort out what went on and figure out, I should say Zoom, and try to figure out why it's not working the way it should. I haven't used this laptop in a long time, which is probably part of the issue.
Yeah, Microsoft is probably asking for a donation, some way, shape, or form, and who knows? All right. Any other questions for Tom this afternoon?
Yeah, I could.
Go ahead.
I got one question. I'm just curious. Do we know where cosmic rays are coming from?
That's a great question. And the answer is yes, we do. They come off the stars. You have a supernova explosion that shoots out a bunch of them. So when you look, we have one cosmic ray hitting one a minute in every cubic centimeter on Earth. So that's more than what you can count with your fingers. That's a huge number when you start looking at it. So they're out there. One of the things I find interesting is when we try to weigh the weight of the galaxy, that we don't count cosmic rays, which are these basically protons and other particles. And it's difficult to get that count, and you wonder how much of the weight of the galaxy is included in a simple proton.
Yeah, it's just amazing that you're detecting something just as we do with light or infrared or anything else, I suppose. But it's traveled literally light years to from the supernova explosion, as you said, to visit us here on Earth. That's hard to wrap my mind around. That's all.
Yeah, back before we had the computers take over everything, I had discovered 10 supernovas. First one on this planet to see them. Can't talk about beings on other planets elsewhere. But it was interesting why it lasted.
How did you find supernovas?
I'm sorry, go ahead.
How did you find supernovas? How?
Oh, how do you detect them? You take two images and you flash them back and forth. And our eyes are extremely good at detecting small changes when you flash two images. So you'd get a bright spot on an image. You'd take a look. You'd save that image and then you'd send it in. And the next night, someone would make a confirmation image to see if it was there or was it just something else. So that's basically how we did it. Kind of a two-step process. I was beaten out by folks in Japan, and the last couple of years they would find it ahead of us. They'd be a little bit ahead in time and do the discovery first. Then I had a friend of mine map that out of all the galaxies in the image. and he sent it to me. Everything was identified, and I kind of laughed. I said, yeah, it would be nice if it was that easy, where you could look and see the names of all the galaxies and such. Well, folks, truly enjoyed. I'm not sure what happened here with the inability to bring Zoom up on this machine, but there's a simple reason for it, and I will hunt it down like a dog and find it.
No, I appreciate your time, Todd, in both in preparing and presenting both. If you do want to send me the slides, I can post them along with kind of our meeting minutes, and then folks can watch the video and work through the slides, and maybe that'll help them a little bit too. But again, thank you very much for your time today.
Yeah, I'll be delighted to send you the slides so that the folks can have them. Unfortunately,
and maybe a screen grab, a screenshot of the muon detector with one being detected, I think would be appreciated as well.
Yeah, that's also in the slide set.
Ah, okay, good.
So,
you still have the Geiger counters, and can you have another student repeat the experiment better?
yeah, hang on, I think we have a way to do this.
Well, I do have a public service announcement in the meantime. I see the HamSCI.org website is up and running again. So whatever the problem was, Nathaniel found it and fixed it. So
yep, I have been diligently working on that in the background.
The traffic's rolling in.
That's right. I'm starting to do some additional maintenance things on the website. I'm doing them on a clone of the website, not the actual one right now. So hopefully once I have the clone upgraded the way I think it needs to be, then we can move over to it. But we'll cross that bridge when we get there.
Very good.
Very good. Yeah.
So one other announcement, the AMSAT South Africa. So AMSAT has multiple AMSAT organizations around the world, but the AMSAT South Africa is having their technical symposium this Saturday, and I'm the keynote speaker. And so if you'd like to get up at 4:30 a.m. Eastern time and watch a recording of me giving the keynote talk, you can do that. And then I have my student Owen, who's going to be talking about the Personal Space Weather Station, and they have a number of other interesting talks. And I think one of the things that's nice is they have a number of talks that really synergize well with what HamSCI is doing. They have a talk that's going to be on meteor scatter and using MSK 144. And so that, of course, synergizes well with our meteor scatter QSO party project. They also have a South Africa noise monitoring project, which can synergize well with what we're doing with the Personal Space Weather Station. Of course, we're doing more than just noise, but that's certainly one thing we can look at. So I encourage you to look at their website. The person who puts it together, his name is Hans. He's really great. They actually provide all of the Yagi antennas that the ARRL sells and uses in the ARRL Teachers Institute. So that actually comes from Hans and AMSAT South Africa. So check out their technical symposium. If you don't want to get up at 4:30 in the morning Eastern on Saturday, they are recording it so you can watch it at a later time. So
here's the muon detector. As you can see, it's a fairly simple device.
Where are the Geiger counters?
Under the lead sheet is the Geiger counters.
Okay. You have two lead sheets or only the one?
There's two of them there that they're stacked on top of each other. And then I started the program again. So if we can look here, if you can see this.
We're getting the very top edge of the laptop screen, that's all. There you go. We're tilting down, tilt a little further.
Yeah, it's just simply counting. And you can see some come together and then you get a separation. So both counters have to trigger at the same time.
What is your window for at the same time?
Say again?
What is your time precision for at the same time? Within a half a second, within a quarter second, within what?
Milliseconds. Microseconds, actually microseconds.
Okay.
Both AND circuits have to trigger at the same time. Both sides of the AND have to be true to get the output. And as I sit here, I'm listening to the Geiger counters click off. And you'll hear one, then you'll hear one, and then you'll hear two of them together.
Did your student try taking this apparatus to different heights in a tall building? Or up a mountain?
Yeah, can you repeat that?
Something a student can do is to take this apparatus at different heights away from the Earth. So climbing a mountain and taking a measurement every 100 feet or whatever, or climbing up inside a stairwell in a tall building, you can see an effect.
The theory here is that we've got a very small receiving area for the muons. And that muon has to hit both Geiger-Muller tubes at the same time for us to get them both true and get an output. Typically, background radiation hits one or the other. And I'm not sure I can give a real good explanation for that. But the lead shields tend to reduce the amount of background radiation. Certainly doesn't get rid of it.
All right, we're nearing the top of the hour. Any last minute questions for Tom? Otherwise, we'll draw to a close this evening, I think. Nothing else. Well, great. Well, thank you again, Tom, for your presentation, and for all your work with the students and whatnot too. We are in an interesting time in our history where science is sometimes looked down upon and whatnot, but it's good to know that many of us, a lot of people in this organization, are supporting young people, and people like you are doing it as well. So thank you.
Well, these STEM schools are amazing. Science is a big thing there. Science, technology, engineering, math. Now they've added some other things to that. But to see the work that these kids produce in their junior year is amazing. I mean, I'm just it's well beyond anything I could have done in my junior year. Of course, they have a little bit better resource than we had.
Well, that's encouraging for the future for a lot of reasons. So,
Yeah. The interesting thing is Gwinnett County, which is where the school is in Georgia. There's a lot of foreign students who are first generation Americans, and they're the ones that appear to be working the hardest. There's been some comments from the parents here saying these foreign students are working too hard and showing up our kids. You got to make them stop. And that's the absolute wrong answer. My take is the parents should be after their kids to work. Take away their toys, make sure they do their homework and learn. I say that being a horrible student in high school.
yes, competition and drives a lot of results. The company I worked for, I'm a retired engineer as well, and we had a very strong merit system for our compensation, and the people who worked hard and contributed the most received the most at the end, and that worked out pretty well, I think.
Well, that was the same with the company I worked for, that there was merit pay.
All right, well, we've reached. If there's no other closing comments, we'll call it a week.
One more question.
Thanks. Yes, yeah, sure, Glenn.
One more question. Sorry, I'm late. Have any of you interacted with something called the Neutron Monitor Database, the NMDB? It's a database of neutron monitors that are like 50 or 60 or 70 of them that are spread all over the place. And it has a wonderful API into their backend database, and you can pull out, history of their neutron monitors that are, from Virginia to Nevada to all over the United States and the world. So it's called nmdb.eu, and it's a pretty interesting site. And I was looking at it, regarding the personal weather stations and stuff like that. And I was trying to figure out, they have a really simple detector. And I don't know if that's something that if we could look at some future integration of something like this. So they call it the one-stop shop for cosmic ray data, right? That's what they call it on the internet. And I thought it was very interesting that neutron monitors around the world, and people just volunteer and professionals put their data into this thing, and it's really pretty amazing. So it could be something that a local student could do, right, where they could build their own and say, hey, during this time period, I got a count of 37. Right, and he might find a local detector somewhere within 300 or 400 miles and see that they got 600. Okay, so there could be something like that. I don't know if anybody's heard of it or if you guys have ever seen it, the NMDB. Nope. Okay. All right.
Thanks for that. I just pulled it up. I'll take a look at it.
Yeah, it's very interesting. Yep.
Good. All right, everyone. Well, thank you very much again. Have a great evening, and we'll see you all hopefully again on the next HamSCIence Zoom session. So long, all.
Can I talk to
Bye-bye,
you, Gary?
everybody.
Yes.
You want to keep the recording on?
Oh, thank you.